So good morning friends. So we have already discussed about a topic that is called precipitation, and today we are going to solve some of the problem, some of the numerical based on the topic is called precipitation. Okay, precipitation. So I actually assure you that none of the question you will get out of this question which I am going to solve today. So every question are very conceptual oriented. So I hope you will enjoy the today session. So now you see, this is the first question to ask. So in a catchment there are 6 rain gauge stations are there. So in a particular catchment, so this is a catchment. So in the catchment particular there is 6 rain gauge stations are there. 3, 4, this is 5 and this is 6. 1, 2, 3, 4, 5, 6. So this is not. So there are actually 6 rain gauge stations are there, and it is measuring a average depth of rainfall of how much? 92.8 centimeter, and standard deviation of the value of the recorded in this rain gauge is given you. The sigma is given to you, means the average depth of mean precipitation is given you as this is 92.8 centimeter, and the standard deviation of this individual rainfall from this mean rainfall, it is given you as 30.7 centimeter, and it is the allowed degree of error, how much error you can allow in the measurement, that is given you 10%. So, okay, so now it is asking what is the optimum number of station is required, means what is the optimum, how much station actually required in that particular catchment. So let's solve this question. So this is the question. Okay, this is the question to you. So here the average mean precipitation is given you. This is the question number 1. So average mean precipitation is given you 92.8 centimeter, and the standard deviation is 30.7 centimeter. Okay, so we can find out the coefficient of variation. Coefficient of variation formula is what? Coefficient of variation sigma standard deviation by mean precipitation into 100. This is the coefficient of variation formula. So we can calculate the coefficient of variation in percentage. So this is 33.08 percentage. Okay, coefficient of variation, and the allowable degree of error is given you as 10%. So the optimum number of, so the optimum number of rain gauge, optimum number of rain gauge required, that is n will be equal to Cv by e to the power whole square. Okay, so now you put all these values. So the number of rain gauge is required, that is 10.94. so you have to round up to 11 number. Suppose it is coming 8.34, so you round up to 9, do not make it 8, so always 9. So 11 number of rain gauge is required in that particular catchment. So now you go to the this one. So the correct answer for this question will be option number D. So option D is the correct answer for this question. Okay, so now we will go to the second question of today class. So you read the question. So this is the question, second question to us. In a catchment, so there are 5 rain gauge stations with coefficient of variation how much? How much rain gauge stations are provided? 5 rain gauge stations are provided with a coefficient of variation how much? The coefficient of variation is given you as 33%. Okay, then the percentage of accuracy in the existing network in the estimation of the average depth of rainfall. What is the percentage of accuracy in the estimation it is asking? So I already told you. So percentage of accuracy, that is nothing but 100 minus percentage of error. This is the only. So we have to do only 100 minus 33. So that is coming out to be how much? So you go to this one. So now so here actually number of rain gauge station will be provided. It is given how much? So number of rain gauge station provided, it is given you 5. So 5 number of rain gauge are provided. Okay, this is provided, and the coefficient of variation is given you 33%. That is coefficient of variation is given. Let's look that problem. So see the problem that is given you. Yes, it is coefficient of variation, not actually this you cannot do. So this is coefficient of variation is given you 33%. So we need to find out the what is the admissible error in the measurement. We have to find out what is the admissible error, what is the degree of error will be allowed in the estimation. So now the optimum number of rain gauge station will be equal to CV by E to the power whole square. Okay, so this number of optimum number of rain gauge provided or required, that is 5. Okay, so coefficient of variation is 33. So we can find out, estimate the error in the estimation. What is the error allowed in the measurement of the rainfall? So percentage of accuracy, what? This is 100 minus E. 100 minus E. So if you do this one, that is coming out to be the percentage of accuracy, that is 85.25%. This is the percentage of accuracy. So this admissible error or this allowable error, you remember, this should not be more than 10%. This should not be more than 10%. So now, so if you see, the correct answer for this question will be, this is option number B. So option B is the correct answer for this question. Now you see the question number 3. The coefficient of variation of the rainfall for 6 rain gauge station. How many rain gauge station are there? 6 rain gauge station in a catchment what? So this coefficient of variation is given you. This is 29.54%. The optimum number of station in the catchment for a admissible error. What is the error is given? 10% is the admissible in the estimation. 10% is the admissible error is the estimation. So it is asking what is the optimum number of rain gauge station will be provided in the catchment. So very easy. So this n will be equal to coefficient of variation by the admissible error to the power whole square. Okay, it is very easy. So this is the answer, question number 3. So this is the question number 3 answer. Okay, so coefficient of variation is given you 29.54%, and the admissible error in the estimation is 10%. So the number of rain gauge station, optimum number of rain gauge station, this is the optimum numbers of, this is rain gauge station. What is the optimum number of rain gauge station provided in the catchment? So this is provided in the catchment. What is the optimum number of rain gauge station provided in the catchment? So this is simply a formula. So it is coming 8.7. So round up to 9. So 9 number of rain gauge, actually that is actually not provided, better you can say that is required. Okay, that is how much required. Okay, so number of provided is how much it is given? 6 is given. So this is not actually make it correct. This is required. So how much we provided? Provided 6 rain gauge station. So here is required is, okay, required is more than provided. Okay, so there is a deficiency. There is a deficiency in rain gauge station. There is a deficiency. So in order to minimize the deficiency, we have to provide some additional amount of additional amount of rain gauge in a particular catchment. What is the additional number of required? That is how much actually required. Okay, how much is required minus how much is provided. So 3 number of rain gauge station is additionally required in the particular catchment. So what is the correct answer for this question? So the correct answer for this question will be 3. So for this question, correct answer will be this is how much? 3 is the correct answer for this question. Now you see the fourth question. So the normal annual rainfall at station. What are the station are given you? So A, B, C. This is normal annual rainfall are given 170.6. So this is 170.6 at A. Average annual normal annual rainfall, and at B 180.3, and at C this is 165.3 centimeter. So actually these are normal annual rainfall are given. So in 1987 the station B was inoperative. The station B was not actually working in 1987 year, and station A and C recorded annual precipitation. Annual precipitation, average annual precipitation is how much? This is 153.0 and 145.1 centimeter. But B was not operating in that year, so B could not able to measure the precipitation. So it is asking the annual rainfall. What is the annual rainfall at B in that year, in that 1987 year? What is the actually missing rainfall data? Okay, so these are the normal n value are given and these are the p value are given, but we have to find out what is the missing. We have to estimate the missing rainfall data of station B in 1987 year. I hope it is clear. So now you solve this question. So this is the question to us. So this is the question 4 answer. Okay, so the rain gauge station A, B, C is given, and these are the normal value. Normal value means the rainfall data of 30 years period. Okay, 30 years period of the rainfall data is called a normal. If you take the average of the 30 years period of data, that is called normal annual rainfall data. Okay, and these are the average rainfall data, average annual rainfall data. So in that one A and C is working, A and C is working, and B was inoperative, so we have to estimate the missing rainfall data, but normal average value of both are given. So basically this nx will be equal to this nb, and this is 180.3 centimeter. Okay, so now we have to check. So they have, first of all you have to check, arbitrarily don't use the any of the formula. First you check this this value na and this nb. Okay, so this you have to check, this one, this na and nb are actually within this 10 nx plus minus 10% of nx, and this is nx minus 10% of nx. So this is plus, sorry, and within this value whether they are rising within this range or they are exceeding. So if you find out this nb plus minus 10% of nb, so plus if you do, that is coming 198.3 centimeter, and nb minus 10% of nb if you do, that is coming 162.7 centimeter. So now you check this na and nc are, what is the value? Na is 170.6. so now actually the top limit is coming how much? This is 198.33, and the bottom limit is how much? This is coming 162.27. so now this 170 is how much? 160 to 170, yes, 170 is lying within this, 170.6 is lying within this range. Okay, then 165 also, 165.3 also lying within this range. So we can use simply arithmetic mean method for to estimate the missing rainfall data. If at all one of the data is will not lie within this range, then you have to go to the normal ratio formula. So simply you have to do the arithmetic mean of the recorded value PA plus PC by, this is how, by 2, and this is 149.05 centimeter. Okay, so that is the thing. So you can see, so the correct answer for this question what is the, we are getting 149.1 centimeter. So this is 149.1 centimeter is the correct answer for this question. Now you see the question 5. So in a watershed 4 rain gauge station 1, 2, 3 and 4 are installed. the depth of the normal annual rainfall at the station. Okay, 1 2 3 are given. Okay, 1 2 3 for all value are given, 60, 75, 80 and 100 centimeter. The rain gauge station at 3 went out of order during a particular year. So the rain gauge station 3 was not working in a particular year. The annual average rainfall value for that year recorded at the remaining 3 station. At the remaining 3 station is 90, 60 and 70 centimeter. So we have to estimate the rainfall at station 3 in that particular year. What is the rainfall? What is the actual missing rainfall data in that particular year? So same thing we have to do. Okay, so same thing we have to do. This is the thing. So this is the answer for this question. This is question number 5, solution of the question number 5. So 1 2 3 these are the rainfall station. Okay, and the normal value are given 60, 75, 80 and 100 centimeter. So average annual rainfall value 90 centimeter, 60 and 3 these are working in a particular year and these were inoperative and these were not working. So you have to find the missing rainfall data of the station number 3. So we have to check the limit. So what is the nx here? Nx will be equal to this n3. Okay, n3 will be how much? This is 80 centimeter. So we have to find out this 80 plus 10% of 80, that is 88 is coming. 80 minus 10% of 80, that is 72 centimeter. Now you have to check all these value are actualizing this 72 to 88 or not. First you check n1, is it lies between? No. So n1 is not rising, then nothing is required to check more. So now we cannot use simply arithmetic mean method because n1 is 60 centimeter, so it is less than 72, it is not lying within this range. So now directly we have to use normal ratio method. So now use the normal ratio method formula. So now as this is not lying within this range, okay, so we are using the what? Normal ratio method. We have to use the normal ratio method. So P3 will be equal to, this is formula is what? Px will be equal to, this is nx by m into this is P1 by n1 plus this is P2 by n2 plus this is P3 by n3. So this is the thing. So n is the how much rain gauge station actually provided. Okay, actually provided. So actually provided means which are operated. So 4 rain gauge stations are there, out of 3 are in operating condition, 3 are operating condition, so that is will be equal to m. Okay, so this is 80 by 3 into 90 by 60, 60 by 75, 70 by 100. So the missing rainfall data at station number 3 in that particular year, how much? 80 centimeter. Okay, so the correct answer for this question, so the correct answer for this question will be 80 centimeter. So 5, so this is the 80 centimeter is the correct answer for this question. Okay, now you solve the question number 6. So rain gauge D was inoperative for a part of the month during which a storm occurred. The storm rainfall recorded in the 3 surrounding stations A, B, C is how much? A, B, C. D was actually inoperative. So which was inoperative? So this D is one inoperative. So A, B, C are recorded how much? 8.5, 6.79 centimeter. If the annual average rainfall for the station is this is 75, 84 and 90 centimeter, then the missing rainfall storm at that particular station is how much? Okay, so you have to find out this one. So annual average rainfall, actually you have to find out question number 6. Okay, so now what is the thing are given? So A, B, C, in which A is operating, B is operating, C is operating, but D was not operating. So you have to estimate the rainfall data for station D. So this is the average rainfall data, 8.5 centimeter, 6.5 centimeter, 9 centimeter. D is missing, so D data has not been mentioned. and the normal ratio data are 75 centimeter, 84 centimeter, 70 centimeter and 90 centimeter. So here Nx will be equal to which one? This is 90 centimeter. So this Nd will be equal to this one is 90 centimeter. So now we have to check what is the range. So this is 90, okay, 90 plus or minus 10% of 90. So if you see 99 is the top bound, upper limit boundary condition 99, and the bottom boundary condition is how much? This is 90. So now you check this 75 is lying within this range. So 75 is not lying. Don't check other. One of the data is not lie within this range. Just use the normal ratio method. So this Na and C are not lying. So now you have to use the normal ratio method for the calculation of the missing rainfall data. So this PED will be equal to Nd by M by Pa by Na plus M is the, what is the number of NGO station actually they are in working condition. This is 90 by 3. So 8.5 by 7.5, 6.5. So now the missing rainfall data in that particular year in station number D, that is coming 9.65 centimeter. So 9.65 centimeters. So if you see the correct answer for this question, so this is the 9.65 centimeter is the correct answer for this question. This is the correct 9.65. Now you go to the question number 7. So the intensity of rainfall and time interval of a typical storm are given to you. The time interval given and intensity of the rainfall. So 0 to 10, the intensity is given 0.7, 10 to 20. So within the 10 minutes of interval, the intensity of rainfall is given. So it is asking the maximum intensity of the rainfall for 20 minutes duration. Now you have to actually do 0 to 20, you have to convert. So it is asking the maximum intensity of rainfall for 20 minutes duration of the storm. It is given in the 10 minute duration of the storm. So now you have to convert into 20 centimeter duration of the storm. So this is question number 7. So this is question number 7. So this is question number answer 7. So now it is actually given for 10 centimeters. So here this is the hydrograph. So hydrograph is the graph in between the rainfall intensity versus time. Okay. So now this is given 0 to 10. We can measure this is 0.7. This is 1.1, 2.2. We actually observed. Now you have to find out for 20 minute duration. So what is that 0 to 20? 0 to 20. This is the time 0 to 20. And the 20 to this is 40, 40 to this 60, 60 to 80. Total 80 minutes duration is there. So we divided into 20 minutes duration. Now what is the total rainfall within the duration 0 to 20? So this is the total amount of rainfall within this duration. So total amount of rainfall, if you find, that is what? That is actually area of the hydrograph. Okay. Total amount of rainfall will be equal to, so total amount of this rainfall will be equal to what? This is area of this hydrograph. Okay, area of the hydrograph. So this is 0.7 into this 10. Okay, all are in minutes. So this is not, no units will be required to convert. So 0.7 into 10. This is the first area, and second area is 1.1 into 10. Similarly, you can find out 20 to 40. So this is the area 20 to 40. Okay, so this is 2.2 into 10, 1.5 into 10. Similarly, 40 to 60, the area, this one the 40 to 60. So 40 to 60, the area you can find out 1.2 into 10, 1.3. So now this is 60 to 80 area. So 60 to 80, it is coming 0.9 into 10. So all you are actually finding out in total rainfall within the duration. Now we can find out the rainfall intensity will be what? The amount of precipitation divided by the duration of the rainfall. Okay, how much total rainfall has occurred in that particular duration, that is called as intensity of the rainfall. So I1, if you do, this is the total amount of rainfall, this one, this is the total amount of rainfall. What is the duration of the rainfall? The duration will be, this is 20 minutes, duration is 20 minutes. So simply we are doing So this is the total amount of rainfall by 20. So this is 0.9, this is mm per minute. Okay, so now I2 is how much? So simply you have to divide this by 20. So this is 1.85 millimeter per minute. So this is I3. So this simply total amount of rainfall, this is the total amount of rainfall divided by this is 20. So this is 1.5 millimeter per minute. So this is how much? I4 will total amount of rainfall by 20. So this is 0.65 millimeter per minute. So you check out of this what is the maximum intensity of the rainfall. The maximum intensity is how much? So maximum intensity is coming out to be, this is 1.85 millimeter per minute. Now we can also draw the hydrograph. So this is the rainfall intensity. Here rainfall intensity is millimeter per minute, and here we can tell the time in minute. Okay, so within the 0 to 20, what is the intensity? So within the 0 to 20, this is 0.9. So we can draw a 0.9. So then 20 to 40, what is the 20 to 40? So 20 to 40, what is the intensity? This is 1.85. So 1.85 we have done. So now 40 to 60, what is the intensity? This 40 to 60, the intensity is 1.25. So now 1.25. Now 60 to 80, what is the intensity? This is 0.65. So this is 0.6. So this is the actually hydrograph for 20 minute duration of rainfall. This is a 20 minute duration hydrograph. Again, if you want to convert 40 minutes duration of hydrograph, you can also convert. So that is the thing, maximum intensity here 1.85 centimeter. So here the answer is for this question is 1.85 millimeter per minute. This is the correct answer for this question. Okay, now this is the last question. Next question I will solve next class. So by depth area duration analysis, the maximum average depth over an area is 10.4 kilometer square. So area is given you as this one is 10 to the power 4. This is kilometer square. Okay, so due to 1 day storm, first day the duration of storm is 1 day, it is find out to be depth of the how much? 47 centimeter. Okay, that depth is coming out to be, depth is 47 centimeter. For the same area, now area is not changing, for the same area the maximum average depth for 3 day of storm can be how much? Now actual duration, earlier it is 1 day, now the duration has been changed to 3 day. So it is asking the depth whether it is less than, greater than or equal to. So already I told you in depth area duration analysis, I already told you. So this is the depth area. So this is the depth area duration analysis. So in the depth area duration analysis, so see, for a particular, if the catchment area, the area on which the storm is happening, if that is constant, that is not changing, so if the duration of the rainfall, is increasing, then depth also will increases. So suppose this T1 here, now you see this one, so this is the first duration of rainfall, this is will be equal to, this is T1. Now the area is how much? The area is 10 to the power 4 kilometer square. Now the duration of the rainfall is actually changed to T2 is 3 day. Okay, so now if you extend this one, so now the depth of the rainfall will be, this is the depth, so this will be definitely, it will be greater than 47 centimeter. Okay, so the correct answer for this question will be, this is, so this is the, which is greater than 47 centimeter. This is the correct answer. Okay, thank you for today class. I will solve this question, the rest of the question in the next class. So thank you.